So with our linear work, remember we've talked about the general form, well, the gradient y-intercept form actually of a line. What's that again?
Y equals mx.
Yeah, y equals mx plus c. And so you can see this line here. The first example, you've got your gradient and your y-intercept. Now, when you first started looking at lines, the first thing we looked at is the idea of filling in numbers in a table and then using that table to graph a line. So if you ever get stuck, we can always revert back to this method. Now, we get into methods that are a little bit more complicated than this, and sometimes we forget that actually this method is still okay. And to plot a line, you actually only need 2 points. Once you've got 2 points fixed, you can't maneuver that line in any other way or in any other orientation. Often we choose a third and maybe a fourth point just so we can have a bit more accuracy, making sure that, you know, we are angled exactly right. But you actually only need 2. So if you've got a more complex equation, you can always revert back to this method. And so let's start with this method that you would have learned in probably year 7. Substitution. Certainly substitution you learnt. So where we see x, we replace it with x in the rule, and then we calculate the value. 2 times negative 2, subtract 1, so that's negative 4, and then we subtract 1, so here our y value is negative 5. And from there we can plot the point. When x is negative 2, y is negative 5. There's our first point for that particular line. We do it again. When x is 0, again putting in 0 for x into the rule. 2 times 0 is 0, and then negative 1, subtract 1, so negative 1 becomes our new y value. So when x is 0, y is negative 1. Pick another point. Well, I've given it to you in the table. When x is 3, 2 3s are 6, take 1 is 5, and so on. Now, I've chosen 4.5 just to show you they don't have to be whole numbers or integers, but they can be. But there's no reason why you can't plot a decimal figure. So with 4.5, 2 times 4.5 is 9, subtract 1 is 8. So then we can plot that point as well. 4.5 against 8. And then the idea is, if you want to use a ruler, or well, you should be using a ruler to plot your line. Hi, thank you. But for me, I'm just going to quickly do it like this. Now, if one of those points are out, you know you've done something wrong. All of those points should map onto that line. So what we've drawn is all the points that actually fit that rule. Y equals 2x minus 1. Every single point. We've plotted a handful of them. We've plotted 4 of them. But actually every single point on this line, and there's an infinite number of them, they all follow that rule. So I can pick a value here, as long as I've drawn my line correctly. 5 should match 9. That point is on the line. Sometimes you might be asked a question, is the point on the line? And so you can see that maybe from the diagram, or maybe from thinking about, well, give me an x value, does it match the given y value for that rule? Every point. Here's another one. 1, 1, for example. I know they're exact points, but any decimal arrangement that fits that rule is also going to be on that line. So there's an infinite number of points. That's what we're drawing. We're drawing the function, it's actually called. We're drawing the function that maps this particular equation. Drawing the linear, it's a linear function, it's a straight line. And the reason why it's a straight line is because it's got a constant gradient. You're going up, or in this case it's up, by that same amount each time. So that fixed gradient fixes that line into position. And having that y-intercept, well, we look at the gradient and the y-intercept, gives you a start point. So the y-intercept being -1 here. So when I say a start point, because we're going to start looking at another method to drawing this line rather than filling in the table of values, a bit more sophisticated and something that you would have covered but later, not so much in year 7. Okay, have a look at this next one and let's plot that one as well, give you some time. So this one, yeah, the rule is a little bit more complex. So if we look at the first value, x is -2, 7 subtract -2 divided by 2. Now we do need to follow rule of order, so we've got to do that division first. So 7 subtract, so -2 divided by 2 is -1. So 7 subtract -1. And then when we subtract a negative, that's the same as adding. So in here, after all that, our value is 8. You should notice here that the coefficient of x is -1/2. That is your gradient, remember? So it would make sense that as x goes up, your y value should be going down. So have a look at the next one. This one's a little bit easier because it's 0. So 7 subtract 0 and 2, well that's 0. So it's 7 subtract 0. Or just 7. This one, 7 subtract 4 on 2. And then the last one, well, that's not going to be a whole number, but that's okay. It's not too bad. 7 subtract 5 on 2. What are we left with? 5 on 2 is 2.5. So we should be left with 4.5. Or you could write that as a fraction if you wanted to. So now we can plot those points. 5. No, the graph, yeah, on the one above. So 5 and 4.5 is 1 point. Then you've got 4, 5. You've got 0, 7. And -2, 8. So using your ruler, this time I've figured out what I'm doing here. So let's just spin it around. And if I've plotted this correctly, they should all be in a nice straight line, and then I can draw my line. It is a good idea, I didn't do this for the first one, when you've got 2 lines, to make sure you label each line. It's probably obvious for the first line. So this is the gradient y-intercept method. So let's go through. What do we remember about that? Does anyone remember anything from what they did in previous years about graphing lines using this method? No? Sorry? Yeah, so with the number next to x is the gradient. So that's how much we go up or down by every time we increase x by 1. And the other number is the y-intercept, and usually that would be our start point. So if we're looking at graphing, the first thing we should do is start at the y-intercept. That's the method. We start at the y-intercept. And then we step out the gradient. So you've got each unit increase in x, y will either increase or decrease depending on whether the gradient is positive or negative. So that's the 2 ideas, but the most important thing is you start at the y-intercept, and you've got to remember to do that. That's it. There's no excuse for that, really. Start at the y-intercept. That is it. So if we look at the first one, line A, 3x plus 1. It's a lot quicker than filling in the table of values. This is why we do it. Start at the y-intercept. There it is, 1. Next step is step out the gradient. The gradient, what's the gradient? 3. So for each unit increase in x, in other words, as x goes up by 1, what happens to y? It goes up by 3. There's another point. X goes up by 1, y goes up by 3. There's another point. X goes up by 1, y goes up by 3. You only need a few points. you might like to, sometimes if the you don't have many and you want to be accurate in the lower quadrant, you might want to back project one, down 3 and across 1, just to keep that same pattern. And then you take your ruler and you graph your line, and it's done. Oops. So this one is, and then usually we extend it out and we put arrows because this function exists all the way through. So that line we've just drawn, every single point on that line satisfies that rule y equals 3x take 1, like I was saying before. So it's not just the points we've used to step it out, it's every single point on that line. There's an infinite number of them. You can see I'm drawing a whole heap here. There is an infinite number of them. Can be decimal, doesn't have to be. It doesn't have to be whole numbers. So for example, if I've got x is 1.1, so just past 1, y should be, don't know, I've made a mistake. That should be a +1. Sorry, not a take 1. That wasn't working. So what I was saying, if x was 1.1, then y should be 4.3 or thereabouts. And you can see that's it there. Just flagging a point to show you that we can have decimals as well on the line. Try the next one yourself. What do you do when it's negative? You go down. So if you've got y equals negative 2x plus 3, we start at the y-intercept, there it is, at 3. But this time we go down 2, because the gradient's negative. So when x always increases by 1, y will decrease this time. And you can see by doing that across to the right and a decrease of 2, you can see you've got a negative gradient, which would make sense. You can back project a couple if you want. You don't have to do that many, but it does help a little bit to get that accuracy on your line, get that angle right. And there it is there. So we start at the y-intercept. That's the key with this method. And then we step out the gradient. So that's that one. Next one, y equals x minus 4. Go on, you do it. Y equals x minus 4. So y equals x minus 4. Our start point is negative 4 on the y-axis. And the gradient is? No, it's the coefficient of x. What's the number in front of x? 1. Which means we step out 1 and up 1, out 1, up 1, and so on. Literally, as x goes up by 1, so too does y. So again, taking your ruler and drawing a line through those points. And then the last one on this page, y equals negative 3x. Where do we start with this one? What's our y-intercept? 0. Good. Yeah, y-intercept is 0. So we start at 0. And it is negative 3x. So we're stepping out negative 3. When x goes across 1, y goes down by 3. So once you've practiced this a bit, it's a pretty cool method. We follow the same procedure. We always start at the y-intercept and then step out the gradient. Now, if you were doing this, you could rub out the steps just to make it a bit nicer on paper. Or once you get the hang of it, you might not need to put those steps in. You might just put the dots in. Up to you. So in that line in orange, every single point that satisfies that rule is on that line. So if x is 10, y is going to be negative 30. If x is 3, y is going to be negative 9. If x is negative 10, y is going to be positive 30. The points that follow that rule are on that line, and that is it, no other points. All right, let's keep going. What do you think happens here? What's different about these equations compared to those other ones we've just graphed? Yeah, the gradients are fractional. So we could still use that same process that we used before, but the problem is, if we increase, with this first one, if we increase x by 1, y has to go up by 2/3. Now, how are you going to plot 2/3 on the graph? It's very difficult to do that exactly. And so what we would do instead, what would make it a bit easier actually, is to plot our rise and our run, because by definition, remember, the gradient is rise over run. So the rise over the run is 2/3, which means you need to go up 2 and right 3. So we always go right. It's the rise is either up or down. Depends if it's negative or positive. But the same process occurs. We still always start at the y-intercept. That is a given. So starting at 1, and we're going across 3 and up 2. Across 3, up 2. Some people find this one actually easier than the previous. We still are doing essentially rise over run in the previous. Our run's always 1 though in those previous questions that aren't fractions.
Whenever it's like, say it's negative and it's rise over run, do you go...
So you always go right and then you drop.
Yeah, always
Yeah,
right.
always right. Now you could back project now that we've done a few, just to get a couple more points on this side. And then we get our ruler. And like I said, once you get the hang of it, you can just plot the points. You don't need to do the triangles necessarily. So extend with arrows, and this is y equals 2/3 x plus 1. So last lesson, where before our assessment, we looked at, from the line, can you tell me the equation? So you should be able to do a quick mental check of that once you've drawn your graph. There it is. I start at my y, I find my y-intercept and I find my gradient. There it is. 2/3 x is the gradient, 2/3 is the gradient, times that by x, and then the y-intercept is 1 plus 1. So we've got a start point. Our start point, the y-intercept is 3, and then the rise is -5. And the run is 4. So we always go right 4, but then we've got to drop 5. So right 4, drop 5, right 4, drop 5. And then we can back project. I've done one here where we go up and left. Up 5, left 4. And then I think that's about right. We can draw our line. And just do a quick check, quick mental check. Yeah, y-intercept is 3, gradient is -5/4. It should be, your rise is, well, your rise drops by 5. That's more than what your run is, which is only 4. So it should be a little bit steeper than the previous. All right, let's try the next two. So 1/4 x subtract 2. So where do we start with that one? Y equals 1/4 x subtract 2. Where do we start? Yeah, we start where y equals -2. There's our start point. Now 1/4, rise is 1, run is 4. So we're going across 4, up 1. Across 4, up 1. And then that takes us off the grid. We could kind of extend it a little bit, or we could back project just to get another point out there. And then set up our ruler and draw our line. Whoops. Oh, this one doesn't want to line up for me. So our run of 5, starting at 0, run of 5, drop of 3. Run of 5, drop of 3. And so then, again, we could back project just to get another point. And then we're done. So just finishing off with this last formal set, these lines have their equations, and we've practiced this before. They've got their equations in a different form to y equals mx plus c. So if we want to graph them using our gradient y-intercept method, we've got to rearrange. We need to divide by 2 this first one so we can get it into our standard y equals mx plus c form. Now we practiced that. This is why we practiced that, early last week or late the week before. We're dividing both sides by 2. And the point of doing that is so we can get y equals, and in this case 4 divided by 2 is 2. Remember, we've got to divide every part of that side, so including the 6.
So is that it then?
And that's it for this one. Yeah, y equals 2x minus 3. And then from there we graph, like we just learnt. So I'll give you some time practicing the rearranging and then drawing the graphs. You've got 3 others to do, 4 graphs to do. To undo the plus 4x, subtracting both sides by 4x. I'm going to write that, so 3y equals, I'll write that as negative 4x plus 6. You could write it as 6 take 4x. And then we divide by 3. So 6 divide 3. So it's important that you are dividing the whole side by 3. When we first did this, I was actually doing it where I think I did it like that, where you actually, just to remind you that you're dividing all by 3. Next one, there's a couple of ways we can do this. Possibly the easier one is to add 2y to both sides, so we end up with 2y equals 3x plus 8. Just alleviates negatives that way. So undoing the take 2y by plussing 2y. And then that is actually what we call the real general form of a line. This last one, or the second last one, in fact the last 2. What we're doing is the gradient y-intercept form, what we're trying to rearrange them to. And then finishing off like the previous one, dividing by 2. And then that last one, how do we rearrange? Best thing to do with that take 5y, get it positive. Particularly with that 0, we can add 5y to both sides. And then I've got 10 plus 2x, or I would prefer to write that as 2x plus 10. Just because then we've got the gradient first. But remember, dividing by 5. Both parts to that other side. The 2 and the 10. So you've now got 3 other lines you can graph. So with this next one, the y-intercept is 2. You've got negative 4/3 as the gradient. So we go right 3, drop 4, right 3, drop 4, and so forth. And then pulling out the ruler and drawing. So we'll keep going, drawing the last couple. So that's what our equations should look like graphically. Just to finish off with, we are going to look formally at horizontal and vertical lines. So they're the really easy ones to draw. Which ones are the horizontal ones? Gradient 0, they have the form what? Yeah, y equals. So the horizontal ones are the y equals ones. because they have 0 gradient, 0x plus whatever that y value is. And so literally they're the easiest ones to draw because we're just going straight through y equals 5 or whatever the number is. So y equals 5. There it is there. If I can get the rule straight. And then we just go straight through. Done. So we can't get much easier than that. Yet sometimes students forget about the horizontal and the vertical ones. Vertical are a little bit more challenging just to understand that. Remember the gradient is undefined. It's a vertical line. Gradient is undefined. So just x equals. Straight through. Every value on that line has x equals whatever it might be. X equals -2, for example. So that's a vertical line. Straight through. Or x equals 0, well that's your y-axis. X equals 6.5, straight through 6.5. If you've got a ruler, best to do it that way. But y equals 1.6. But never mind. These are your horizontal lines. So now just to finish off with the last few minutes, we're just going to practice those on our CAS calculator. Do you remember how to do that? So get your calculator out. And it is in graph and table. When you are drawing on your class pad, if you've got a grid that's not like that, that is the default setting. So you can go to this icon here, click on it and go default, okay, and that will give you the default setting. It's a reasonable spread of x values and y values that will fit many of your lines, but not necessarily all of them. So you might need to change that setting. And by doing that, you go to your view window. So pressing that icon again, you can change your x values and you can change your y values. So you've got a larger range in your y values and the larger spread in your x values if you want. All right, and let's just graph a line. Y equals 3x minus 2 looks pretty good. That's the one in the example here. Y, just typing in, sorry, you don't type in y equals, y is already there. You're just typing 3x minus 2. Why won't you subtract? There we go. And then you've got to tick the graph that you want. And then you've got to hit the graph icon, which is one on the far left. And there it is there. Okay, so that's how we use our calculator. Let's just do one more. I don't know. 2/3 x. It wants to do it. Two-thirds x plus 2 will do. And just to show you, there's your second. So you'll notice the 2/3 x should be not as steep because it is a gradient that is not as steep as 3x. So the 3x one is quite a bit steeper. It is also got a different y-intercept at 2 compared to -2. So, but they're both positive gradients. We could change that to have one of them to have a negative gradient if we wanted to. And then you would get it sloping in the opposite direction. All right, and we're done for today. What I want you to just practice over the weekend is just some of these questions. Just picking out maybe the last 3 in each set. Those 3 and maybe those 3. Just graphing and then a couple here. Maybe just graph a couple there. And just a couple of special lines. Perhaps. All right, and then they're the answers. So